welcome to our digital learning day. I hope everyone is staying safe and warm with all of this snow today. Basically, kind of just going over the agenda, we are going to review your homework from last night, which most of you finished in class before you left on Tuesday, but that was to draw the electron dot notation of fluorine, hydrogen, and nitrogen. Then we are going to talk about Lewis structures, actually applying those little electron dot notations to molecules and how we draw molecules and can kind of see what's going on inside of these little compounds that are made up of different kinds of elements. So we're going to learn how to do that. We're going to do some practice with it. You guys are going to pause this video, and yes, you are going to pause it. You're not just going to watch me do the answers. You're actually going to pause it, and you're going to do these 8 and see how you do. You'll complete them on your own, and then you come back and watch me fill it out, and you can kind of see if you were on the right track or not. And then after we do that, you guys have a little bit of homework that will be due on Monday, and that is to complete this Word document, which is just simply called Lewis Structure Worksheet. There are 16 problems on here, and hopefully after we do the practice problems together, you'll kind of have a good idea of how to do that, and you'll be good to go for Monday's class. So without further ado, let's go ahead and look at your homework from last night. Okay, so the first problem that you had for homework last night was fluorine, and according to our steps for drawing electron dot notation, you simply just write the element symbol. So for fluorine, that is a capital F. And the next step is to find out how many valence electrons it has. So I'm going to look over here at my periodic table, and I find fluorine, which is right here, and it is in group 7. And group 7 have 7 valence electrons. So I need to put 7 dots around this fluorine. So to do that, the first thing that I'm going to do, according to the rules, is put 2 dots on one side. And it honestly does not matter which of the 4 sides you place them on. You just simply want to pick a side. So I'm going to pick one side, and I'm going to put 2 dots on it. Then after that, you have to be able to put 1 dot on each of the other 3 sides. So I've got 2, there's 3, 4, and 5. Now I need 7, so I need 2 more. So I can go back and double up any of these single dots, and it truly does not matter which of those 3 dots you choose. So here is number 6 and number 7. So as long as your fluorine has 4 sides, 3 of those sides have 2 dots, and 1 side has 1 dot. That is a correct answer. So your 1 dot may be on the left, maybe on the right, maybe on the top, maybe on the bottom. It really doesn't matter, as long as 3 of the sides have 2 dots and 1 has 1. The next problem is hydrogen. So our symbol for hydrogen is H. I'm going to check over here on my periodic table, and I'm going to find hydrogen, which is right here, and it is in group 1, which means it has 1 valence electron. So one side, doesn't matter where it is, has 1 dot, and you're done for that. Next problem was nitrogen. So our symbol for nitrogen is a capital N. So I'm going to go to my periodic table, and I am going to find nitrogen, which is right here, and it is in group 5, so 5 valence electrons. Start with one side and place 2 dots. Really doesn't matter which side. You're probably going to get tired of me saying that, but it really honestly doesn't. So there's 2 of the 5 that I need. Here is number 3, number 4, and number 5. And I don't need to go back and double up because I have the 5 valence electrons that I need. And that, in essence, is electron dot notation. So hopefully you got yours correct. If you have any questions, please do feel free to email me, and I will be checking my email throughout the day today, and I'll get back to you as soon as I can and answer any of those questions. So having the electron dot notation of an individual element doesn't really help you that much. But what it does help you with is creating molecules, putting these individual elements together to create the molecules, which are two or more elements bonded together covalently, as per our definition from Tuesday's class. So let's talk about what that looks like, and that is Lewis structures. So at this point, you may want to go ahead and start filling out your 6.2 notes here in your OneNote notebook. You don't have these yet. We didn't get a chance to fill these out on Tuesday. So the Lewis structure, kind of same way we did the electron dot notation, I'm going to go over the steps with you, and then we'll do some examples with it. So, to draw a Lewis structure, first thing is to draw the electron dot notation of each element. Okay, so you pull out each individual element in that molecule and you draw its electron dot notation. Second step is you fit each notation into the others like a puzzle. So imagine each element is a puzzle piece, and you somehow have to fit them together, and they can only go in a very specific design in order to create the molecule. So think of it as putting a puzzle together. Step number 3 is to replace the two dots between atoms with a dash. I know that might not make sense right now, but I promise you it will once we actually apply this. So get those 3 steps written down in your notes so that you have them to refer back to as you're doing some practice problems. And we are going to start with the molecule of CH3I. So this particular molecule is made up of carbon, 3 hydrogens, and 1 iodine. So according to step 1, I am going to draw each electron dot notation for each of the elements in this molecule. So I'm going to start off with the C, carbon. Carbon, if you look at your periodic table, is in group 4. So it's going to start off with 2 dots, 2 dots on one side, and then 1 dot on 2 other sides. Now it has a blank space, and we're going to come back to that and talk about that in just a moment. We have 3 individual hydrogens, and as we know from our homework, hydrogen has 1 valence electron. So 1 little dot there for the hydrogen for each of those 3 hydrogens. And then we have iodine, and iodine is in group 7. So that means 2 dots on one side, 3, 4, 5, 6, and 7. All right, so there's each of our individual elements. Now, I said we would come back to the carbon here, and you notice there's a blank space on this carbon. So one side has 2 dots, and then 2 sides have single dots, and then one side has nothing at all. So what sometimes elements will do, and carbon pretty much does this every single time, is when it ends up having a completely blank space on one of the sides, it will actually move one of its little electrons to that empty space. So carbon ends up looking like this with a single dot on all 4 sides. Okay, so this happens when you have an element that on one side has 2 dots and on another side has no dots. It'll split itself up, and so it at least has 1 dot on each of the 4 sides. Okay, so now we need to fit these guys together like we would puzzle pieces into a puzzle, and they only fit a very specific way. What I always like to start off with is to find the central atom. What is kind of that starting piece? What is that piece of the puzzle that all of the others are going to fit into? So if I look at carbon here, carbon has the ability to fit on all four sides. It's got single dots, and remember, each side can fit up to 2 dots. So it's got 4 sides of individual dots. So it could fit 4 different puzzle pieces into itself. Each hydrogen only has 1 empty space because it just has 1 dot. Iodine over here has 1 empty space. So carbon can fit 4 puzzle pieces into itself. Hydrogens can fit 1 puzzle piece into itself, and iodine can fit 1 puzzle piece into itself. So your central atom is going to be that atom, that element that can fit the most puzzle pieces, the most other atoms into itself. So in this case, carbon with 4 empty spaces, that is going to be our central atom. Okay, so I'm going to redraw carbon here with its 4 dots, 1 on each side. And then I'm going to fit into it all of my other little puzzle pieces, all of my other little atoms. So I'm going to take, and it again does not matter what side you start on. So I'm going to take one of my little hydrogens, and I'm just going to start here on the left, and I'm going to fit, I'm going to fit it right there. Okay, so I take the one little dot from the hydrogen, and I fit it in to that one single dot on the left-hand side of carbon. And so now hydrogen has 2 little dots, and we know that hydrogen is completely happy with 2 valence electrons. I'm going to take the second hydrogen, and I'm just going to put him in on the top here. And I'll take this third hydrogen, I'll fit him in the bottom. There's really no rhyme or reason to this. I don't know why I picked the left top and then the bottom. Just whatever feels right at the time, I guess. So then you're going to take your iodine here, and we take this one single dot that's at the bottom of this iodine, and I'm going to fit it in to the right-hand side of this carbon. I'm going to make sure that I include all of those extra dots around the iodine, okay? All of those electrons need to come with it. So now if we go back and check, hydrogen at the top has 2 electrons, so hydrogen's happy. This hydrogen on the left-hand side has 2 dots, so he's happy. The hydrogen at the bottom has 2 dots, so he's happy. This iodine has 2, 4, 6, 8 electrons. He's a happy camper. And the carbon in the middle has 2, 4, 6, 8 electrons. So he's happy. So every single one of our elements is happy because they all fill up their valence electrons that they want. The 8 that the carbon and iodine want, and the 2 that the hydrogen wants. Now, right now, we've just gone to step 2, the fill each notation into the others like a puzzle. What we want to do now is step 3, which is to replace the 2 dots between atoms with a dash. So I'm going to rewrite this as hydrogen dash carbon dash iodine. Don't forget iodine's extra little electrons around the outside edges. And then I have my dash hydrogen at the top and my dash hydrogen at the bottom. So we just simply replace those 2 dots that connected 2 atoms with a dash. It just makes it prettier, it makes it nicer, and it's going to make our topic we're going to talk about in Chapter 7 a little bit easier. Okay, so that's Lewis structures. That's how to draw a Lewis structure. So I tell you what, let's do the first one of these practice problems together. So the first one is NH3, and you should have these 8 problems in your guided notes right now as well. So I'm just going to kind of go off to the side here, and we are going to do sorry, my pen is not working really well right here. NH3. So first step, draw the electron dot of each element. So we have, oh goodness, my pen is just not being happy here. So we have nitrogen, which is in group 5. So 1, 2, 3, 4, 5. We have 3 hydrogens, and we know hydrogen with 1 valence electron. Each of them is going to have 1 dot on one side. All right, so now that we have our individual elements, we want to find the central atom, that one atom that's going to be kind of the center of our atom that everybody else is going to be connected to. So nitrogen here has 3 empty spaces because it has 3 single dots, and remember each side can hold 2. So right now it has 3 empty spaces, and each of the hydrogens have 1 empty space. So nitrogen is going to be our central atom because it can fit the most stuff into it. So I'm going to redraw. Oops, I don't know what's going on here. Hang on a sec. There we go. I'm going to redraw my nitrogen, and I'm going to put the 2 dots here. Oh, goodness gracious. There we go. Sorry about this. So we've got our nitrogen with our 2 dots, and then our single dot on each of the other sides. And then I'm going to connect my hydrogen to those empty spaces on those 3 sides. Okay, and then I'm going to redraw it. So I've got nitrogen in the middle with the 2 dots, dash, hydrogen, dash, hydrogen, and dash, hydrogen. And that is our answer. That is NH3. That's the Lewis structure of NH3. So what I would like for you to do, and I've kind of changed my mind here as we have gone through these notes, I think what we'll actually do is I would like for you to complete problems 2 through 8 on your own, and that is going to be your homework for Monday. So we'll do the Word document. We'll do it Monday during class. I would like for you to do problems 2 through 8 for Monday's homework, and I will check those at the beginning of class on Monday. So send me emails if you have questions, and I will get back to you as quickly as possible today. So good luck, and I hope you have a good snow day.